Hey guys, welcome to distance learning. Just pretend I'm right there with you in the classroom. But today and this week, we're going to look at two different really important trig concepts, law of sines and law of cosines. And today we're just going to look at law of sines, which is basically a ratio, just like trigonometric functions. But in this case, they are for oblique triangles. So triangles that do not have right angles. And here you can see two different pictures of what an oblique triangle might look like. So we cannot use our regular right triangle trig, SOHCAHTOA sort of things for this, but we can use something called the law of sines. And the law of sines is just ratios between the side length and the angle. And that is it. So you can be using law of sines when you're given these circumstances: side angle angle, angle side angle, or side side angle, which is going to be an ambiguous case, which we will talk about at the end of this lesson. But it's pretty straightforward. So you look at what you have in a triangle. So in this example 1, solve means find all the sides and all the angles. The first thing we notice is that we have two angles, and we know that all angles in a triangle add to 180. So we can just subtract the other two angles to get our third angle that we're missing, and that would be 71 degrees. So I know right here this is 71 degrees. And now I need to solve for these missing side lengths. And to do that, I literally use these ratios from up here. Very straightforward. So I'm going to look at A over sine A, and I'm going to look at C over sine C, because this is the information I've got here. So I can say that A over sine of 46, which is the angle straight across from it, is going to equal C, which is 56, over the sine of 63, the angle straight across from it. All right, you cross multiply. A sine 63 equals 56 sine 46. Divide both sides by sine of 63. And you end up with side length A being approximately 45.2 inches. And that's one of our sides. Then we need to do the other thing, the same thing, to find our other side, which is side B. So we can just say that B over sine 71 equals 56 over sine 63. And notice we use the same 56 over sine 63, 56 over sine 63 in both of them because they're just ratios. Cross multiply, so B sine 63 equals 56 sine 71. Go ahead, divide both sides, and you get B is around 59.4 inches. So we have now solved for the three missing pieces. We know that A is 71 degrees. Angle A. We know that side length A is about 45.2 inches, and we know that side length B is about 59.4 inches. All right, so on to the next one. We have a new triangle, similar to our last problem. We have angle C and side C. We can find this missing angle B by just taking 180 minus 82 minus 64, and we end up with 34 degrees. So we know that angle B is 34 degrees. And then we know that we have an angle here, and we need side A. So you can set up your ratio any way you like. A over sine 64 equals 14 centimeters over sine 82. So it's just whatever is across from it is how you're setting up these ratios. You go ahead, cross multiply and divide. You get that side A is about 12.7 inches. And then we need to do the same thing for side B. B is over sine 34. And we can just set that up again with side C. Cross multiply, divide, and you get that B is approximately 7.9 inches. I should have an approximately since we rounded here. Uh-oh. My pen died. Not sure why.